Hey party people, my name is Mia. I am a naturally certified tutor. I also tutor at my community college and I'm also a student instructor, but this video and this channel is not affiliated with them at all. I do live in the state of California, so everything covered in this Chemistry 101 series that I'm doing on this channel is required by the UCs and the CSUs. You know, requirements may vary depending on the state that you live in, so anyways, let's get into it. So one of the first things we do in chemistry is something called dimensional analysis. And this is to prepare you for stoichiometry, which we will be doing later on. But basically, it's about converting between measurements. So in the United States, we have our feet, our inches, yada, yada, yada. Most of the world uses the metric system, but we also have the SI, which is the Standard International System. Anyways, I want you to take a minute, pause the video, and write these down, okay? Now, whether or not you have to memorize them is up to your professor. My professor, I had one professor that had us memorize them. I had one that didn't, okay? Maybe if I'm feeling nice, I will link my, what is it called? I will link my Quizlet down below. Anyways, we're gonna have to ignore the fact that I do use this whiteboard as a painting palette. I will get a new one, but I don't have a new one right now. So, okay, for the sake of this video, you need these. Step 1, you need to find your variables, and you need to be able to identify what you're given, your unknown, and your conversion factors are. What are conversion factors? Good question. So there are a few keywords that are there to kind of give us a clue into what our conversion factor is. Those words can be rate, they can be per, they can be for every, etc. So for example, for every 1 pound, we have 454 grams. This is also the same as saying that for every 454 grams, I have 1 pound. In a word problem, you are more than likely going to see it more like this: 454 grams per pound. Okay, this little fraction symbol, that's our per, that's our rate, that's our for every. So our first problem, an Olympic swimming pool holds 490,000 gallons of water. How many cubic centimeters of water is used to fill 7 pools? And if you asked the mayor of Paris for the 2024 Olympics, the answer is none, because they don't got Olympic pools, they're swimming in the Seine. Anyways, that's crazy. So I prefer to find and identify my unknown, and I work backwards and I can identify the given. So for me, it is most obvious to identify the unknown first. The unknown in this problem is cubic centimeters. It says how many cubic centimeters, so I need to know how many cubic centimeters. Our conversion factor in this problem is going to be our 490,000 gallons of water per pool, okay? And then that means that my given is the only other number in this problem, which is 7 pools. So we are going to start with our given. We will pretty much always start with our given. So you can set this up one of 2 ways. I prefer the train track method, which would be this one up here, but you can set it up more like a traditional math problem, which would be like having all these fractions that you will end up multiplying together. All right, so we start with 7 pools. No matter which way you do it, what you need to cancel out has to be on the bottom, okay? So I have 7 pools, and my conversion factor is 1 pool per 490,000 gallons. So on the bottom, I'm gonna have 1 pool for 490,000 gallons. As you can see, now that we have pool on the bottom, we can cancel that out, okay? It is extremely important that you keep your units all the time, because if you do not keep your units, you're going to get confused and you're going to get the wrong answer. All right, so units. I need to get from gallons to cubic centimeters, so go back if you didn't write those common conversion factors earlier, but we need to get from gallons to cubic centimeters. So the first thing I'm gonna do is I'm gonna convert gallons to quarts. Now that I have canceled out gallons, I'm left with quarts. And For me personally, I know the conversion factor from quarts to milliliters and then milliliters to cubic centimeters. So we're going to continue on and do that. So I have quarts, and that has converted to milliliters. And now I have milliliters, and that has converted to cubic centimeters. And our unknown was cubic centimeters. So we have found the unit that the problem needs us to be in, and we are done. Now, for either one of these cases, you are going to multiply across the top and divide across the bottom. Let's break that down just this once, okay? So I have 7 pools, and I'm going to multiply that by my gallons over pools. I'm going to multiply that by my quarts over gallons, and then milliliters over quarts. Finally, I have my milliliters over cubic centimeters. And you can just press equal, and my answer is going to be 1.3 times 10 to the 10th cubic centimeters. And let me just show you what that looks like in its entirety. To be honest, I'm just going to switch back to the yellow notepad because that whiteboard is like too small and also so janky. So anyways, this is what it looks like in full. We have Japan and Korea are drifting apart from each other at a rate of 0.473 centimeters every year. How many years will it take to drift 5 meters apart? Well, we have to find our unknown, our conversion factor, and our given. Our unknown, the question is really asking how many years, so our unknown is going to be years. Our conversion factor is going to be 0.473 centimeters per year, which leaves us with the only other number left in the problem, which is 5 meters. So our given is 5 meters. We are going to start with 5 meters. Because I'm starting in meters and my conversion factor is in centimeters, the first thing I'm going to do is convert from meters to centimeters, which gives me 0.473 centimeters for every year. And we are done. You can go ahead and punch that into your calculator. This should give you, I'm going to round that up to 1,060 years. Next. Oh, that was not cute. Next. Okay, so I have one blue whale can swim 160.9 kilometers a day. How many days would it take for a blue whale to swim 5.7 times 10 to the 8th centimeters? That means my unknown is days, my conversion factor is 160.9 kilometers per day, and my given is the only number left in this problem, which is 5.7 times 10 to the 8th centimeters. Since we're starting with centimeters and my conversion factor is in kilometers, what I'm going to do, because I do not off the top of my head really know the conversion factor from centimeters to kilometers, so I'm going to go from centimeters to meters and then meters to kilometers. So I have 100 centimeters in 1 meter and 1,000 meters in 1 kilometer. That leaves me with just my conversion factor, which I will be putting on the bottom. And on the top, I will have 1 day, which is perfect because that is what we were looking for. We were looking for days. I'm going to put that in my calculator. And I'm going to say that this whale was extra fast today and round that to just 35 days. I have how many decades are in 2.2 times 10 to the 7 minutes. So this question is interesting because the unknown, the question is how many decades, okay? And I only have one number. So that has to be the given. The given will be 2.22 times 10 to the 7 minutes. We do not have a conversion factor in this problem, all right? So both minutes and decades are measurements of time. So I'm basically going to go from minutes until I can build up to larger amounts of time. So I know that there are 60 minutes in 1 hour. I also know that there are 24 hours in 1 day. I know that there are 365 days in 1 year, and there are 10 years in 1 decade. And now that I'm in decades, I am done and I can calculate. And I'm going to say that is 4.22 decades. Okay, so that is your introduction to dimensional analysis. Again, this is just like in preparation for stoichiometry. But I will see you in my next video on density and specific gravity.